So let us discuss this next example on splitting field. So the question is, you are to construct the splitting field over Q for the minimal polynomial x cube minus 1. So for that, what we do, we first check whether this is a minimal polynomial, irreducible polynomial or not. If yes, what is its root? Its root would be x cube minus 1 is equal to 0. So we obtain x cube is equal to 1 or x is equal to 1 to the power 1 by 3. So all the cube roots of unity, that is the root. So we know one is alpha, another is some say alpha and say alpha bar. These are the three roots. Say this is also one of the cube root of unity, right? So x is equal to 1 is its root. That means we can write this x cube minus 1 as the product of x minus 1 and x square plus 1 plus x. You can get it by division with x minus 1. When you divide this polynomial x cube minus 1 with this x minus 1, you will have this polynomial. Now we call this polynomial as px and we assume that omega be its root. If omega be its root, then in that case we can construct a new field. Say this was given to us Q, the field of rationals. This is the irreducible polynomial px. So whatever is the ideal generated by this polynomial, that would be the maximal ideal, and this whole structure, that would be a field. This is one of the results that we have studied earlier. If this is a field, this would be the extension field, where we adjoin the root for this, we adjoin an element which is the root for this minimal polynomial px. So we have assumed this root to be omega. So this is isomorphic to this field. So now what is the degree of this field over this field? So that is the next question. So that degree we also know, that is the degree of the minimal polynomial of this element omega over q. What is the minimal polynomial? It is x square plus x plus 1, and its degree is 2. So that means the degree of this extension field q omega over q is also 2. So that means we found its degree. Next we have to find what are the elements which are present in its basis. So for that we have a results that says if you have some polynomial px having degree n, and if u is a root of this polynomial px, so then we have the elements in the basis as 1, u raised to power 1, u raised to power 2 up to u raised to power n minus 1. So here n in our case is 2, so we will go up to 2 minus 1. So that means we will go up to power 1. So we would have 1, and what is u? U here is omega, right? So we would have 1 comma omega as the elements present in the basis. So this rational number omega q omega forms the splitting field of the polynomial f of x over over the field of rationals. So this is all about the splitting fields. So we have studied about what are splitting fields. We have seen various examples of this splitting field. Then we have also seen the existence theorem for splitting field. We know for every polynomial there exists a splitting field for sure. We also saw that that splitting field is unique in nature, so we have this uniqueness theorem with us. Then we saw that every splitting field implies the field is finite. Moreover, it is also an algebraic field. Next we saw again an example how to calculate the splitting field for some given polynomial which is defined over some given field. So I hope this is clear to you all.